Hey everybody, this is Alex Merced, developer advocate here at Dremio with another video about a SQL function. And in this video, we're going to be going over XOR, this function right over here. This is actually pretty interesting. Now, if you're not familiar with bitwise operations, the idea is that, computers store everything in bits, zeros and ones. And using that, you can basically take advantage and store lots of information in really compact ways if you know how. So the idea here is we're going to have a features enabled field that is an integer, but the idea is that it's going to correlate with sort of um, the base 2 or binary version of that number. So for example, if the field here, let's say was 3, okay, then basically what it would equal is, okay, let me think about that. So basically 1 would be this, 2 would be this. Okay, so then 3 would be this. Okay, so essentially 3 would equal this, okay, in base 2 or in binary numbering. So the idea is that if you know this, then we can take advantage and say, hey, each of these numbers represents true or false for a particular feature flag. And we can represent the features that are turned on and off via a single integer, okay, that expresses sort of the number of bits that you need. Cool. Okay, so just to kind of understand sort of like the nature of this particular sort of usage. Okay, so the idea here, we have 5 as these are the different numbers of the feature flags that are turned on. Okay, so you can see here that's basically what the binary version of 5 would look like, the binary version of 3, and so forth. Okay, so now what would happen is that we want to know sort of like the difference between sort of one user and another user's features that are turned on. Maybe we're doing a comparison. Maybe we have some sort of like base user that we are using as sort of like as a comparison piece. The idea to kind of see, okay, how are other users turning features on and off based on a comparison. So essentially what XOR is going to do is that it's going to compare each digit of the binary number, of the binary version of the number, and then generate a number based on that difference. Okay, so for example, in this situation, we're going to end up comparing user 101, which is this, to user, okay, in this case, we're going to, to each individual user. So we would compare it to like user 102. Okay, so let's think about that comparison. So if I were to compare 0101, or let's do that, 0101 to 0011. Now let's see here. Okay, first we go to each digit, and then it would be a 0 if they're the same, a 1 if they are different. So it's like true that there's a difference. Okay, so the first digit is going to be, well, the same. The second digit is different, and the next digit is different, and the next digit is the same. So essentially you would generate this number, which is actually the equivalent of the number 6 in binary. So essentially what this is going to return you would be 6 for that comparison, because that represents sort of the difference, okay, between the two sort of states. So using this, again, you can store the data about which features a user has in a very compact way. And then here I can kind of see, hey, I can compare two users and which features they have turned on and off in a very compact way. And that's sort of like the benefit of this sort of bitwise operations and using bits to kind of represent true and false and taking advantage of that where you can. So now let's run that query. Okay, so this one's a little bit more conceptually involved than many of the previous ones. I find bitwise operations pretty fascinating when you really think about like just how much you can do with something very simple. Oh, let's see here. Did I mistype something? Let's see here. Let me run that again. Okay, so what did I forget to change? Oh, okay. My mistake is that I did not change my context. So what happened is that I was reinserting the records into the same table as I did when I did my test run. So then technically this subquery was returning multiple rows because now there wasn't just one row returning an ID of 101. So that was my bad. Okay. So easy fix. Let me actually set the context as I should have set right before we ran that query. Awesome. Okay. Yay for errors that describe the problem. I love it. Okay, so it basically told me that that subquery has a return one value. That led me to go inspect the subquery to kind of understand, hey, why would this return more than one value? And then it clicked. Oh, I did not change my context, so I was reinserting into the same table. Okay, so again, good error messages make life all the better. I love good error messages. Okay, so now let's try this again in the proper context. Okay. And again, that's the beauty of sort of like using the Dremio Lakehouse platform. Again, you have this really great SQL IDE that's going to give you sort of descriptive errors so you can troubleshoot things. It's going to give you syntax highlighting. So a lot of times I can discover problems in my SQL before I even have to run the code because I'm going to get that kind of highlighting. So overall, it just kind of gives me a really nice environment to write SQL. But see, now everything is nice and ran successfully. And now we can see, and again, we did that comparison of 102 to 101. We did that manually earlier, and we came up with the number of 6. Okay, so as you can see, that is accurate. It will come out with the number of 6 when it does that comparison. And that's essentially what this does. Again, it's for, unique use cases, probably when you're tracking, again, software features and trying to track, or you decide you just want to track a bunch of sort of true-false statements as a binary to condense the amount of space that you're using to save those questions. These bitwise operations can be sort of a good way to sort of do that more efficiently. Trade-off being that bitwise operations may be harder to understand for many consumers other than having sort of several true-false fields. Cool. But with that, my name is Alex Merced, developer advocate here at Dremio. I'll see you all next time.